problem we'll be looking at is find minimum in rotated sorted array. Suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array nums equal to 0, 1, 2, 4, 5, 6, 7 might become this array if it was rotated 4 times, or this array if it was rotated 7 times. Notice that rotating an array simply means that each element is shifted to its right except for the last element, where the last element becomes the first element. Given this array and the elements are unique, return the minimum element of this array. You must write an algorithm that runs in O log n time. Let's take a look at example 1. We have nums equal to this array, and output is 1. We have this array, and the output is 0. It's simply the minimum element of the arrays, and this array we have 11. So this problem is rather straightforward in that you can simply use Python's min function to find the answer, but we want to write an algorithm that runs in O log n time. Notice how the problem states that the array is sorted, and we want to run that algorithm in O log n time. These two are huge hints to tell us that we should be using binary search for this problem. Let's go to the whiteboard and see how we can solve this problem. We have an array looking like this, and we know the output should be 0. So for binary search, the classical way to do it is to have a start pointer and an end pointer. And at each iteration, as long as start is less than n, we will calculate the mid pointer. That will be calculated by the start index plus the end index divided by 2, and it's an integer division. So to find the mid pointer, we'll have to find this equal to s plus e, integer divided by 2. In this case, it would be 0 plus 4 divided by 2. We would have mid pointer pointing here. Now, what do we do after we have the mid pointer, right? We need to check if the value that is pointed by the mid pointer is greater than or equal to the value that is pointed by the end pointer or the right pointer. So start, end, left, right, essentially the same thing. So we do this. If nums, which is the array, mid pointer is greater than or equal to nums end pointer, then we reset the start pointer or the left pointer. That's equals to mid pointer plus 1. Why do we do this? Let's for a second say that this were an 8 instead of 0. We want to find the minimum element in the array. So we compare 8 and 3, and we see that 8 is greater than or equal to 3. So this statement here returns false, returns true. If it returns true, we know that the smallest element would be to the right of the mid pointer, because this is a sorted array. That's why we set s to mp plus 1. And we don't want to set it to equal mp. It has to be mp plus 1 because mp is not the smallest element, since it's greater than or equal to nums e, which is 3. Else, so if that were false, what do we want to do? We want to set the end pointer equals mp. Okay, so here we have nums mp greater than or equal to nums e. Else, that means nums mp is less than nums e. So for example, let's go back to our previous value here. Is it 0? So 0 is less than 3. If 0 is less than 3, we set the end pointer to the mid pointer. And this time we don't do np minus 1. Why is that? It's because since nums np is less than nums e, there's still a potential that nums np is the smallest element in the array. Therefore, we just set it to np to give it the potential that it could be the smallest element. And we repeat this process until s is no longer smaller than e. And then in the end, we simply return nums either e or s. Let's go to the code walkthrough, see how we can implement this in code. To start, we have to initialize the values. Let's call it left and right. So we have our left pointer equal 0, and our right pointer equal to length nums minus 1, the last index. While left is less than right, we need to find the mid pointer. So call it mid. And this would be left plus right and integer divided by 2. So this in Python simply means a division and then round it to an integer. Once we have that, we check nums mid is greater than or equal to nums right. If it is, we set left equals mid plus 1. Else would be right equals to mid. We keep doing this until we break out of the while loop, and then we return nums right. See if this works. Okay, so that got accepted. And then it works, it's a success. So that's it for today's video. If you like this video, make sure to like, comment, and subscribe. I'll see you next time.